All right, moving on to a couple more challenging examples for you to see. And what you're going to see a bit later in the book, or later in the homework. You could come across a question like this one. So the fifth one here. So 5 to the exponent 3, exponent 2x equals 5 over 27. So again, the questions you go through, I see that my x is on the 3. So I'm going to have to find everything in terms of common base 3. Can I get the 5 out front to be 3 to some exponent? And hopefully the answer you're saying is no, that's not possible. So you only have one form of recourse here. There's only one action you can do. You're going to divide both sides by 5 because an inverse operation would get rid of it for you since it's a problem. There it goes there. On the other side, and you can check this with the calculator. I'm going to divide the side. If I have 5 27ths, so let's say a pizza was cut into 27 pieces and I have 5, I have to divide them into 5. That means it's going to reduce down to 1/27th. So I end up with 3, the exponent 2x equals 1/27th. So I kind of like that because I know the 27 can be written as base 3. So life is getting better. I know that 27 is equal to 3 cubed. 3 times 3 is 9, times 3 is 27. I'm going to have to make it a negative 3, though, for my exponent, since the 27 is in the denominator. So now, because I have two bases, which are the same, I can now get rid of the bases. I can look at the exponents. So therefore, comparing exponents, 2x equals negative 3. Isolating for x, so now we're back to grade 9 algebra. We get x equals negative 3 halves. Okay, so even the fractions, not nearly as challenging as they were in some of the previous questions you've come across. All right, so what happens if we have multiple x's? So let's take a look at a question that has more than one x term in it. So let's go with a quarter. So in brackets, I have 1/4 x plus the exponent x plus 3, and that's equal to 1/8 the x minus 1. Okay, so for this one, you have two terms that have an x in them now. Okay, so there's an x here and an x here. So that means that, unlike the previous question where you knew what the base was going to be, you have to look at your two bases and come to a consensus as to what will be the common base for both of them. So we have to find something that's common. And 8 cannot be written as base 4. I know people right away think it's going to be 4 squared, but that's 16. So it's going to be a number less than, it's either going to be a number of 4 or lower, okay, since you can't go above 4. So a quarter and an eighth, or if you want to just look at a 4 and an 8, hopefully you come to the decision that it's going to be base 2. And you can keep it as 1/2, it doesn't matter. So for example, you could say I'm going to write this as 1/2. So that would be 1/2 squared is a quarter, x plus 3. And on the other one, 1/2, and when it would be 2 times 2 is 4, times 2 is 3, times 2 again is 8. So it would be cubed to the x minus 1. So I've decided to go with a base of 1/2. Okay, it can be a fractional base. So my bases are the same. I have to clean the exponents up a little bit, though. There's too many exponents. So you need to use distributive law here. Okay, it's a power of power rule. So you use your distributive law. So you end up with 2x plus 6 equals 1/2. And using your distributive law on the other side, the 3 will multiply both of those terms. Oops. We end up with 3x minus 3. Bases are now the same. Okay, so now you can go ahead and compare exponents. So therefore, comparing exponents, I know that 2x plus 6 is equal to 3x minus 3. This is when you need to move all the variables to one side, all constants to another. So subtract 2x from both sides. Inverse operation removes that. So we have x minus 3. Isolating for x, I have to do an inverse operation. We'd end up with 9 equals x. And there's your final answer. So definitely a little bit more challenging when you have multiple bases. So I want to do at least one more example here, and then from there you can move on and try some of the homework. So, number 7, example 7, it's possible to have all three terms. So if I had 1/9 to the exponent 2x multiplied by a 27 equals 9 to the exponent negative x. So in here we have a whole bunch of, we have three terms now. Only two of them have an x with them though, okay? So this base and this base have an x in the exponent. So those are that's the first thing we gotta look for is the terms with the x's. Can we get them written as a common base? 1/9 and 9 can easily be done that way. And we can go with base 9, or you could go with base 1/9. So I'm going to show an extra step here to show you what I did. So in order to write that as base 9, 1/9, it would have to be 9 to the negative 1. And that's multiplied by 1/27 equals 9 to the negative x. Next, I'm going to get rid of the extra brackets here. So I'm going to multiply those exponents together. Okay, so I'd end up with 9 to the exponent negative 2x multiplied by 1/27 equals 9 to the negative x. All right. Now, here's an example where we have variables on both sides. So we have 2x, we have a term with an x here, a term with an x here. Remember we said you want all the variables on one side. So can we get the variables to one side? I asked myself what's happening on this side, and I have 9 to the exponent negative 2x multiplying a fraction. So can I undo that? For sure. So I can divide both sides by 9 to the exponent negative 2x, 9 to the exponent negative 2x. An inverse operation would cancel those out. So I'm left with 1/27 equals 9 to the exponent. And off to the side, I'll do it over here. Take the numerator and subtract the denominator, minus 2x. Oops. Sorry, I don't have enough subtraction signs in there. So remember, division, you're subtracting exponents. Negative x minus negative 2x. So that's negative x plus 2x, which gives you x. So that means we have 9 to the exponent x. Now, can we get this in the same base again? So 1/27, can I write it as base 9? No, but both of them can be written as base 3. So 3 squared would give me the 9. 3 to the negative 3 would give me 1/27. Bases are now the same. So therefore you compare your exponents. So negative 3 equals 2x. Divide both sides by 2. And we get a final answer of x equals negative 3/2. Now some people are going to ask, could I have gone to base 3 right off the start with this question? And the answer is absolutely. There's more than one way to do this. I tried to chunk it into small steps, but if you notice that all three bases, you can write all three numbers in the same base immediately, you can definitely jump to that. Will it cut down on the work? Maybe a little bit. It'll look a little bit different though when you go through and do your solution. All right, so that gives you an opportunity and a heads up as to what to expect with the homework. Solving equations using common base is one of the major concepts you want to make sure you go through. Homework's here at the bottom. It's also on your syllabus from the start of the year. So you're looking at doing those questions, answers are there. And if you need any help, you know that I'm in class next day to give you a hand. Good luck.